Hello and welcome to the DSO Imager channel. My name is James, and tonight I'm going to go over a two-panel mosaic that includes the Flame Nebula and the Tadpole Nebula. If this is your first time to my channel, I certainly would appreciate a subscription. I've got a lot of good content on this channel. Now, my typical videos of late is I do walkthroughs through my workflow of my imaging, and that's what the plan was for this one. Unfortunately, the Pixinsight project did not get saved, so the image is finished, and a lot of the work has been saved as individual image files, but it's not going to be possible for me to step through everything like I typically do. So what I thought I'd do is do a really quick processing just to show the basics of how to get everything done, specifically getting the mosaic going, and then maybe skip over the typical stuff that I do with all the curves work and show the finished product. So let's get started. Alright, so each panel the information was captured with my Stellarvue SV70T. It's a 70mm triplet refractor with a focal length of 336 millimeters. That does include the 0.8 reducer. And the camera is the ASI 1600 mono, and I'm using an Astrodon 5 nanometer HA filter, and then O3 and S2 are astronomic 6 nanometer filters. So each panel's got about 24 hours, give or take a little bit. The total count for anyone that's interested. These are all 10-minute subs, 600 seconds, and so there we go. That's the breakout. What I ended up with. Alright, so let's first take a quick look at the data here. So here we go with HA. Get a nice look. This is not stretched. We're just using the auto stretch here. And there's O3. And here's S2. Oh, one other thing I forgot to mention is that for the final image, I did drizzle the data. This data here is not drizzled, and so when you get in, you can see how blocky the stars are, and that's because this camera and scope combination, it gives me a image scale of 2.33 seconds, arc seconds, or thereabout. And so yeah, it's a little what do you call, undersampled, and so you do get some blocky stars. I mean, generally you can leave it, and what I'm going to do in this video as I process this, we're not going to work with drizzled data, but I'll show you the difference with the final product that was drizzled, and you can see that you end up trading some of this blockiness for a little bit of extra noise. That's basically what it comes down to. But anyway, anyone that's concerned about image scale and whether having an image scale of 2 seconds or more is a problem, I mean, you'll see how it looks on this image, right? Ideally, you want to be around 1 second or so, but I mean, it's not too bad. I always consider those recommendations on image scale as more of a guideline than a hard, fast set rule. Alright, now these images were registered, but you can see we've got some cropping to do. And so the way you can handle this in Pixinsight is grab the dynamic crop tool. And then you can apply this crop to the other images. and accept it for the original. Makes cropping multiple images real easy. Like I mentioned, everything's got to be registered for this to work correctly. So if they've all been registered, and if you're using in Pixinsight, if you're using weighted batch preprocessing and you put all your channels in there, everything will spit out already pre-registered. Reason I ran into this, just a side note, is I had an issue with some subs and I had to run the HA frames separately from the S203, and so that's kind of what contributed to what we just saw there. But anyway, if you see that, that's how you do a dynamic crop. Alright, so next we need to run dynamic background extraction. And I'm just going to use my standard common settings here. And you really want, I mean, it's dynamic background, right? Background is the key word there. So if it's avoidable, you don't put a reference point where there's any nebulosity, and it needs a minimum of 3 positions to run. So that's just what I'm going to do. I'm just going to hit these 3. I don't want to click anything here because we've got nebulosity in there. Yeah, and that looks pretty good. We'll save that. So we'll do a division, and then we'll do a subtraction. There. Like that. We'll run with that. I'll go ahead and pause the recording and knock this out on the 2 other frames. Okay, so I finished running dynamic background extraction on both sets of files for each panel. There's that flaming star. So now, normally, next step, if you wanted to run some denoise, now would actually be a good time to do it. I'm not going to do it right now. I mean, the noise is actually not too terrible. But now would be a good time to do it. And then after that, if you're going to run deconvolution, now would also be a good time to do this. So deconvolution, I would definitely run, and on this one I ran it against HA on both frames. And I think on the tadpole, I did run deconvolution on the 03 as well, because we had some nice detail in here. And I think on Flaming Star I probably ran deconvolution against the S2. Alright, so let's go ahead and jump onto the LRGB combination tool. We'll put these files together. And we're just going standard Hubble palette here. There we go. We'll call that frame 2 or F2. Oh, it's already in use. We'll call it frame 2C for combined color, whatever you want. And let's do it for frame 1. Alright, looks good. Alright. Why did I do that? Frame 1. I'm telling you, especially on bigger, with more panels, you got to stay on top of it. You can mix yourself up with the naming stuff, and it can be a real headache at times. Now, there's a few different ways to put everything together as far as mosaics go. For this, I'm going to use the image registration star alignment function to set things up, and then I'll use the gradient merge mosaic tool to put them together. Now, in my experience, the star alignment tool, I have better success with the images stretched. So typically, if I were doing a regular image here, especially with Star Exterminator out there now and stuff like that, I mean, this might be a point where I would pull the stars out and then stretch the image without the stars and do my work that way. But for image registration purposes, it's not going to work without the stars, because the stars are what it uses to align everything up. So we're going to stretch these first, and just to make things very easy, I'm going to just auto stretch them both. Now the thing is, the closer these are together, the better your odds are the gradient merge mosaic is going to work well, and you won't see a seam. They'll be blended in. And so using the auto stretch actually is a good way to ensure that they're both getting the same type of stretch here. Alright, and next we need to decide which panel is going to be our reference panel. So the thing is, usually what I do is that whichever panel is the reference, it gets overlapped by the other. And you know, your stars in the corner, at least with my setups, they're not perfect. And so I try to think about setting up or using the frame with the worst stars as the reference, so that the bad stars at the seam will get covered. And actually, which it's this, right? So I'll just look. I think actually both of these frames turned out pretty good as far as stars, so it's not going to matter. But it's just something to think about. If you know that you've got one corner that where the stars are not looking very good, set it up so that that one corner is the one that gets overlapped. Alright, so image registration, star alignment. So I'm just going to use F1 as a reference. Thin plate splines is the option that you want to use. Working mode, we're going to use Register Union Mosaic. And this is just to get the rough template, if you will, in place. So I'm just going to drop this onto frame 2, since I used frame 1 as the reference. And there's our template. And this is a good time to inspect. And I already have a problem here. See this seam here? So I had forgotten to crop. Yeah, I mean, you can see this right here. So this image really needs to get cropped. If you don't crop both frames, this is going to mess up your seam. So it looks like frame 2 needs to get cropped. So I'm going to toss this and crop it real quick. So, I mean, I guess that maybe you can call this an advantage of seeing the processing live, because you'll see all the little mistakes that invariably you're going to encounter yourself, because no one's perfect, right? We all do stupid things, like closing Pixinsight without saving your project. Alright. So, let's try this again. So all these settings are the same. Dropped it in there. And let's see how this looks now, or if we're better. Yeah, see, I mean, the seam is there, right? Because this is just a rough. But now you're not seeing those stacking artifacts in there. Alright, so we'll run with this. So what you do is you take your rough mosaic here, and now you use this as the reference. And we change the working mode to register union separate. And we also want to enable frame adaptation for this step. Slide that guy over there. And we're going to want to apply this to both frames, or panels. Okay, and that's what it does. So here's our separate here, and it just makes us another copy of this. I don't know why it does that, but we don't need it, so we'll close that. So I'll go ahead and pause the recording and apply this to frame 2. Okay, that just finished. So here's our frame 2. We can close that, minimize this guy, minimize this guy. Here we go. Now there's one more step, and it's a step that I had in my early days I would forget about, and it would cause some serious fits. So we need to go back here, and we need to change this back to the default projective transformation and change the working mode to register match. And we just want to match it here. And the reason we need to do this is that these two pictures, they're not the same dimensions. They may be a couple of pixels off. And if you try to use gradient merge mosaic without this step, and they're not identical resolution, merge mosaic will bark at you. So this final step of doing a register match to the rough mosaic is a way of getting these to be identical size. Now I'm just now noticing I left frame adaptation checked. Normally I would uncheck frame adaptation. I don't think it's going to cause any problems here, hopefully not, but if I get a weird result running gradient merge mosaic, then I may come back and uncheck that. So let's see how this works. Alright, so let's go ahead and close star alignment. Let's move these two guys over here. Now, gradient merge mosaic wants you to load up files, so we have to actually save these. Alright, and so I paused the recording and saved them to my hard drive. So let's go ahead and minimize these. Open up gradient merge mosaic. Add files, there they are. Alright, overlay is what I choose. Feather radius, I mean, so this is one of these tunable settings. I've used around 40, 20, whatever. This black point, I've had a lot of success by moving this up at least 1 notch. And then you hit the apply, and let's see. Hopefully this works out good. And I don't know how long this is going to take. I'm going to pause the recording and I'll be back as soon as it's finished. Okay, and we're back. And it actually didn't take that long, maybe a minute. It takes a lot longer with drizzled data, and I'm sure those full frame cameras out there probably take a while too. But let's take a look. How did this work? And basically what I'm looking for is if I can tell where the seam's at, and if there's any kind of distortion. So I mean that's pretty solid right there. I don't see a seam. Don't see any distortion. Not really. And you can see a difference, like the top image is a little less noisy than the bottom image. And I've noticed that sometimes. This is the reason why you want to get the data as close to matching as possible. Total integration time, you know, the moon phases and all of that. They get really good mosaics. You really want to try to avoid it. Oh, there is some problems here. You see this? See how we got some blurriness here? So this kind of thing, there's 2 things that you can do to maybe address that. One is when you're doing your registration, I don't always check it. Is this distortion correction? So that second step where I had frame adaptation, I probably should have done distortion correction. The other thing that can sometimes impact this is in the gradient merge mosaic tool. is tweaking this feather radius. So you can increase it or decrease it, and that sometimes helps with this. Now, for the purposes of this video, I'm going to let this slide. In my finished image, you don't see this. I mean, I think this would probably get tweaked out by adjusting the feather radius, to be honest. I think that would probably do the trick for us. But that's the only area that I had a problem here. Everything else looks pretty good. Alright, so next would be to crop this. And I mean, you know, the way these things always come. I had a little camera rotation. I'd like to get as much of the spider as possible. So maybe rotate this, but by doing this, it's going to impact these corners. So we can actually, oh. There's a piece of the fly. Alright, so the rotation, the reason why I had a rotation, I had some issue where I had to take the camera off and put it back on it. So obviously, what you're seeing here is a couple degrees difference, and that's what's led up to this. So this is another example as to when you're planning your mosaics, you want to have ample overlap. You really want to do about 15 or 20%. It hurts because you lose that screen real estate, but you know, if something happens where you do get some rotation, you're not going to lose it. Let's accept that. There we go. Alright, so that's basically how you use the gradient merge mosaic tool to do a mosaic. I have another video on my YouTube channel where I did a 4-panel mosaic with an ASI 533 one-shot color camera. So if you want to see how this works with the color camera, definitely check that out. Check that video out. I think what we're going to do now is we're just going to go ahead and show what the results were from my processing. What I normally would do at this point is hit this with a star exterminator to pull the stars off, and then start working with curves a lot. So anyway, let's take a look at what I have. Now this should be drizzled data, and here are the two frames again. I mean, that looks the same, right? But if we zoom in, see, no blocky stars. And this stuff was, you can see it looks a little bit better, right? Its deconvolution's been run against this. I mean, you have to go really good. So this is why you run, why you drizzle your data. All right, and the merge mosaic of that came out like this. Let's see if we had some of that same distortion that we got on that live run. I don't think so, but I don't remember if I looked close enough. And no, see? That weird distortion's not in there. And I think the main thing was I had hit the distortion correction. You can see a tiny little bit of a vertical seam here, but when you crop this out, you're not going to get that. And on the other side, looks pretty clean. The bottom frame, I mean, can you see a difference in noise? I mean, not really. And what did I end up with? Well, this is what I ended up with right here. Final image. Lots of work with curves, range masks, color masks. Now if you zoom in, I mean, we have a bit of a grain here. It's not too bad, and you have to get in really close to see it. You guys know I like green. I kept some green in here. You don't see a lot of green too often in Flaming Star. So I kept a little in there. And of course we're going to get a little green here on these tadpoles. I need to point my edge at this image. Alright, so does the grain bother you or not? Well, I ran it through Topaz Denoise just to see. And let's take let's get this comparison here. Now, Topaz Denoise has improved a lot over time. When it first came out, it would really do some funky stuff to your images. I believe I used the low light option, and I used a very light hand with it. All I'm wanting to do is just remove the grain. I'm not wanting to add any additional sharpening effects to it. I'm not wanting to, I mean, if you go too crazy with Topaz Denoise, it can start doing weird things to the data, but yeah. I mean, even at zoomed in at this level, you can't see too much of a difference here, right? But if you zoom in more, there. So we've got some grain there, and the Topaz Denoise did a nice job of smoothing things out without sacrificing any detail. So anyway, there it is. I hope this video was interesting for some guys. I hope I demonstrated that doing mosaics is not really that hard. It's just a time-consuming process. And one could argue that if you had a larger sensor, this was a 1600, so micro 4/3. If I had a full frame, I could have got probably this whole thing nearly in a single frame. But you know what? If I had a full frame camera, I'd probably do a 2-panel mosaic anyway, just to get even more. Maybe I should get a lens instead. So anyway, if you like this, please subscribe. If you have any contents, any comments, questions, please put them below, and have a good evening.